Okay, so I'm here to just have a recording of notes and final thoughts about the Ballistic Pendulum. Uh, it's now fall semester 2022. We did this in the past in 1570 in Physics 1100, and we just did it in Physics 2100. So one thing is I want to make sure you remember that there is a playlist for it, and there is here now the spreadsheet. And one thing I seem to do every semester with this lab is forget that there's no error propagation needed. And you'd see here that we set up. I'm surprised it's so blurry, but you've taken some measurements, and you can see you can take a look at this spreadsheet video of how to set it up. And remember, in the new end, we have the new apparatus that, let's see if I get my, something is missing here on this screen, but I've got this, but where's my little pinwheel? Oh, there it is, right there. Okay. So, oh, and I haven't checked to see if I have the tablet ready to go. Let's see. Mapping. Yeah, so I don't want to do, I want to do just the one screen. I think that would be monitor 2. Yep. Okay. All right. So anyways, recall that basically what we're doing is this is the velocity of the bullet from the pendulum, and that's what I want. I don't want to make it a little bit thinner. And then I go here, yep. I love that thing. And for us, it is about we weigh the masses. We put the capital M we get from the apparatus itself. The little m is the steel ball, and we weigh it. We know the acceleration of gravity, and then there's h. And remember, we wrote it out in class that if you imagine you have the pendulum in its resting position, we know that there is and I'm just rearranging my desk a little bit here. We have the length of the pendulum is from the pivot to the center of mass, and we said, look, we can divide that up into two pieces. I think that's the eraser. Yep. So we can divide it up into a part called A and a part called H. There's nothing, we can always do that. And then we can put, when the pendulum is at its furthest swing, and that would be at the angle theta. And now I could get a little better, a little more clever and precise about this. And that's hard to read as an A. Okay. And so recall that we can always say L equals A plus H, that we divide a line into two pieces, we add the pieces together, we get L, we get the original line. And we also realize L is over here too, it's the length of the pendulum. And now when we look at this, we notice that A over L equals cosine theta. And then we say, oh, we can substitute, we can rearrange this so A equals to L cosine theta. And then we go back here. We need H, so we say that H, this equation here, we rearrange it to be H equals to, let's take a look, A minus L. No, L minus A, excuse me. And then we can substitute in this L cosine theta for A, and that gets us equal to L minus L cosine theta. And of course, at the end of the day, we decided to make it look like this, L times 1 minus cos theta. It's not that big of a deal if you want to leave it like this or to do what I did. So that gets us a bunch of H's. We set up our spreadsheet, and in fact, we shoot it 5 times. We get 5 V bullet from the pendulum. And then we can take the average and the standard deviation of the sample, and then we can do standard deviation, standard error. Then remember what we're doing here is that we're trying to get people to buy our new apparatus called a ballistic pendulum, and we need to show them that it works. And remember, we don't have accurate stopwatches and bullets and cannonballs travel so fast, but we do have the established kinematics rules and law, the equation, and we made it we plugged in numbers, rearranged, and that we did in class, did in the pre-lab. It's on the previous page of this manual, and we can solve for velocity equals to the range we measured, and now we just invert this to capital H and square root it. And I made the mistake of going into saying, oh, well, we need a plus minus on capital H, but you don't. You're going to get 5 V bullets this way from shooting it and recording the range where it lands. And remember, we consider that to be the accepted value. So now, oh yeah, we already know all this, and this fractional energy loss, this is not necessary. We're not going to get into that. We already studied that in elsewhere. And so what we want to do is, we're trying to sell this thing. So we're going to get V bullet from the pendulum, and it's going to have a plus minus V bullet from the pendulum, which is just going to be the standard error. It's all in the spreadsheet. And then we can do the percent error on that determination, which is just going to be plus minus V bullet from the pendulum divided by V bullet from the pendulum. And remember, this is the average of the 5. And we multiply that by 100%, and we get a percent error on that one. But we still, and that just says that we took a measurement using our design of our apparatus, the equation that goes with the design. And this is what we think we've measured. And our judgment is when we take V bullet from the pendulum projectile, right? Let's call it from shooting it, plus minus the V bullet from the shoot. And we do the same thing and get a percent error for that. Times 100. And we'll get a plus minus for that. And now what we want to do is a percent difference. So this is where you add together subtract. And it doesn't matter because you take the absolute value from the pendulum, subtract V bullet from the shooting it, and then you divide it by the average of the two, which is V bullet pendulum plus V bullet shoot, and divide by 2. That's the average. And then you multiply that by 100%. So you want, and that's our percent difference. So we want the percent difference to be smaller than either of the two error bars. And that means then the two measurements overlap each other, and any difference between them is simply because of the error on the measurements. And if we can accomplish that, if the percent difference between the two numbers is smaller than either one of the error bars, then we've demonstrated that it works. So that's what we're looking for in your final logbook. And then, of course, and additionally, any questions that happen to be inside of there. But again, don't forget, there's a playlist here. And even though we did some sims with it, there's plenty of great information here. And in particular, this spreadsheet here. So I'm going to close off this one and get it up onto this playlist for everybody. See you soon.